Hi and welcome to today's video. I've been making good progress since the last video. I've now managed to have trains running on 95% of the track. There's a little bit of cleaning still to do. I've also now started adding the block detection to the LCC nodes and adding them into JMRI. So I'm now going to just show you some trains running, showing that the tracks is working the way I want it. So please enjoy this short video presentation of some trains running before I go into adding the block detection to the first ESP32 nodes. So here we can see the basic node. Now this one would offer you 2 servos and 8 IOs. This can be pushed to more IOs or even more servos if you wished. However, for servos you really need to be looking at powering the servos separately, which is not a difficult thing to do. So this is the very basic and most cost-effective method. Here you can see the transceiver at the back. This is the next node which I'm going to be using quite a bit on my layout. So this again, the sketch on it at the moment is 2 servos and 24 IO. So there's 8 native pins at the moment made available. And then here you can see the I2C MCP 23017. Obviously this one requires more soldering. It seems to have an address of 20, so that one is another cost effective. These I think I just paid £1.69 from AliExpress. As I say, a lot more soldering required. And this one here is our 2MCP version. Now this one again is quite a little bit more advanced. It does require more soldering, but it does make it easier for getting onto the I2C because it's got a double row of headers. However, it does have a very small surface mount 0 ohm resistor here, so you have to remove it on the second device, which is quite simple to do if you've got a steady hand. And then what you'll see here, I've just bridged out the VCC side of it, so that then gives it address 21. I've just put some white paint on, and then I will mark these up as what is the address on them. So again, 2 servos, 8 native pins and 32 extra IO pins. Just remembering certain ones can only be used as inputs, which is A7, B7s. Then this is another one. Now this one is in development. As I say, this is the one where at the moment I'm struggling with the PC9685. These I think have got a fault. So, I need to check out a different supplier and see if I can get it working in the way I want it to. This is the easiest MCP module. If you're only having one of them, there's no soldering whatsoever. If you want to daisy chain them, which I will need to do, you do have to solder in some headers. You can see I put extra headers here. This just allows me to either bring the wire in this way or that way. Another neat solution is this one here. Now this one, a little bit more expensive again, but it does have the jumpers here for setting the addresses. So these are the different modules that you will see appearing on my layout. And at the moment, this is my demo plan for testing, which I use for one of the area groups that I'm involved in. So since the last video, I've changed my mind yet again. So instead of just having one LCC node doing the 25 blocks, I've decided to go with 2. But I've also changed the MCP 23017 for this module to see how these work. And here you can see I've got 2 channels of the Merck DCC block detection unit, and here you can possibly see, not probably going to show up very well, on block 1 and 2 the LEDs are lit because I have got trains actually on track. And then here you can see both sections are now active. So that's the first bit of the JMRI bit done, and I'm happy with the progress. Obviously the next thing I will need to do is connect up all of these, and then set up this module, and I'll show you the setup of the modules in a minute. So obviously we go to our usual LCC configure nodes, and here you can see the 2 nodes I've got. We go into here and we go into the configuration. You can see now it's loading. We go to here. So the first thing I did was change the name so it's something meaningful for me. Obviously change it and then save it. Then we go into the MCP 23017s, and here you can see I've called them all to the names convention that I want. So in port A I'm using 6 of the 8 possible outputs. Obviously number 7 is an output only, although I have had a little play and it did seem to work at the moment as an input, but I wouldn't recommend it. So the first thing I did then is renamed here to BL01, change this to an input with pull-ups. Then if we scroll down a little bit here, you can see here we've got make sensors. Obviously you will have to click save. Now if I just close this down again if I can. I'm trying to do this from a remote desktop, which is not very easy if I'm honest. So if we now go to here, tools, tables and sensors, here you can see all the sensors. Now at the moment some are showing up as inactive and some are active. This is because I've actually already got locos on the track. So if we go to this panel view, what we do is if we go to a block section, I've already created this map, so you know you're going to have to look how you do that. If you get here and then you click edit, you go to here, because obviously I've already decided what I wanted to show as, but if we go to create or edit, we go to here, sensors, and here you can see we can choose the various sensors that we've created already. So that's how we get this to work. And so far I've connected up, I'll have to click done here, sorry, and then back onto this one. And so far I've now got all of these here working, so the first 12 blocks. So hopefully that shows you just what we can do with these nodes. So once again I'd like to give a big shout out to David Harris, who has made this possible for me to do this by reworking the Open LCB single thread library and giving me help with getting the different ESP modules working. So again, thanks very much David, much appreciated.